Well, we're finally going to get through this in 4 videos, and I apologize that this is taking that long, but this is very important stuff, so please, this is not the time to be skipping anything. The main thing with this one problem is understanding the quadrants that we're in, and as a reminder, we don't say positive, we're going to say greater than 0, but that's exactly what's happening here. We want where cosine is positive, and as far as your explanation goes, instead of writing out, cosine is positive and tangent is negative, because I think that's just repeating this, I'd rather see that you either circle the quadrants where cosine is positive. I don't care if you circle them individually or as a group like I just did, or if you put X's in the quadrants where cosine is negative, because we don't want those. And obviously, you don't have to change colors, but if tangent is negative, that means that we cannot be in the first quadrant because all trig functions are positive there. And just to solidify that, tangent's also positive in the third quadrant. So if you wanted to, you could circle here and here. And really, and I'm already aware that some of you, if you were trying to articulate your reasoning, you'd probably be like quadrant 3, because quadrant 3 is where cosine is positive and tangent is negative. And to me, that's just repeating the definition, but that's essentially what this is. I think the justification, I'll actually just pull up his answer key because I'm not trying to hide anything. There we go. He's talking about how cosine is the x-coordinate, which is positive in the first and fourth quadrant. And then if tangent's negative, that means that one of x or y needs to be negative. So that means quadrant 4. I think that's a little busy of an explanation. That's why I'm leaning towards asking you to just circle which quadrant and clearly label, okay, we want quadrant 4. And by the way, Roman numerals, IB is quadrant 4. Okay, well, we don't have to end up in a quadrant. We can also end up on an axis. So anyway, as we're looking at this, if cosine is positive, that means we are either here first or fourth. Now, where is tangent undefined? Well, tangent, by definition, is sine over cosine. So the only time that that tangent is undefined is if cosine is equal to 0. Well, how can cosine equal 0 and be positive at the same time? It can't. This is an impossibility. This is not possible. And as far as the reason goes, cosine cannot equal 0 and be positive at the same time. I kind of wish I wrote smaller. Cosine cannot be 0 and positive. I'll use a big word. Simultaneously at the same time. Cool. Okay, so tangent is positive. So let's keep this straight. Positive here and here. That's where tangent is positive. And then remember, cosecant is the reciprocal of sine. So essentially it's saying the same thing, that sine must be negative. If sine is negative, then cosecant is also negative. That happens in the third quadrant, not the first. I guess if you wanted to, sine is also negative in the fourth quadrant. And again, if you want to use that phrase, all students take calculus, to remember which all are positive in the first, sine is positive in the second, and it's reciprocal. So sine and cosecant are positive. Tangent and cotangent in the third. Cosine and secant in the fourth. And let's keep this straightforward. Sine is negative in the third and fourth. Secant is undefined. well, secant, that's undefined when cosine is equal to, I don't like how I wrote that, is undefined. That happens when cosine is equal to 0. Well, remember, cosine is the x-coordinate at 0, -1. So this occurs on the y-axis. And you could even mention the negative side of the y-axis. I'm actually interested to see what he says on that answer key. So I'm going to pull that up. Whoops. I don't know what I just did. Theta must terminate on the negative side of the y-axis. Yeah, something like that. And then this last problem. And then you'll be ready for the homework. So now they're telling you that theta lies somewhere between pi/2 and 3 pi/2. So remember that pi/2 is up here, and then 3 pi/2 is down here. So we know that our angle happens somewhere in the second or third quadrant. Now we can deduce which quadrant specifically because sine is positive. Well, where's sine positive? Up here in the second quadrant. And more specifically, it's at that ordered pair, -√3/2, comma 1/2. So what does that mean? Well, now we can figure out that theta, if we are good with our unit circle, that's at 5 pi/6. And if you need to reference your unit circle for right now, that's fine, but we need to get to a point where you have everything memorized. And now we can actually figure out cosine of theta pretty quickly because it's the x-coordinate, -√3/2. I'm going to wait for tangent, but we should also be able to figure out secant and cosecant pretty quickly because secant's a reciprocal of cosine. So as I mentioned earlier, if you don't want to rationalize, that is okay, but most math teachers will make you rationalize. And then cosecant's a reciprocal of sine, so the reciprocal of 1/2 would be 2. Now tangent's a little bit more difficult to figure out because by definition tangent is sine over cosine, so that's that 1/2 divided by the sine coordinate over -√3/2. As I mentioned earlier, if you didn't catch it, I'll tell you right now that when your denominators are the same, you can actually just cancel them out. And when you rationalize that denominator, you'll get -√3/3. Now, that rationalizing actually would take, like if you fix that, that would take longer than if you just did the reciprocal of the unrationalized to get cotangent. Otherwise, you could flip this and then rationalize that denominator, and you'll get the same answer. So that's how I would do that problem. Otherwise, I just wanted to share. He squeezed all of this work in right here, which I think is kind of obnoxious, but you can see he gets the same answer. Fills out everything. He even shows how to rationalize, why the 2's cancel out. He did not rationalize, I said that wrong, but cosecant's reciprocal of sine, secant's reciprocal of cosine, and then cotangent's the reciprocal of tangent. And you should be ready for your homework.